Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Today we are going to discuss about one name reaction from the chapter amines, or which is also called as organic compounds containing nitrogen. Let me first write down the title for this name reaction. It belongs to the chapter organic compounds containing nitrogen, and name of this reaction is Hoffman bromamide degradation reaction. Okay, yes, so this is actually a name reaction because it is named after the name of the scientist who invented this, that is Hoffman. Okay, yes, now this reaction is actually a method of preparation for amines. Okay, this is the one of the methods of preparation of amine. This reaction is method of preparation of primary amine. Okay, this is the method for preparation of primary amines. In today's class, we are going to see its detailed mechanism. The mechanism is not given in your textbook, but I am going to explain that mechanism to you in detail. Of 1 degree amine, that is primary amine. Okay, yes. Now first of all, if you observe, this reaction is called as Hoffman bromamide. So what is the meaning of this bromamide? That also we are going to discuss later. Then it is also called as Hoffman bromamide degradation. So what is the meaning of this degradation? That part also we are going to discuss after the mechanism. Okay, yes. So let us start with the mechanism of this reaction. Or first of all, I will write down the general reaction. So the starting material for this reaction is RC double bond O, then NH2. Okay, this is nothing but amide. What is the name of this functional group? This is called as amide. Okay, AMIDE. Now when this amide is treated with the bromine, okay, in the presence of the base like NaOH, or in this case you can use KOH also. Okay, NaOH or KOH. So if you are using this reaction NaOH and KOH, so it will give you, yes, so it will give you the product RNH2. Okay, it is very simple, guys. You simply are going to delete this part from the molecule. Okay, CO molecule is deleted and we are getting the product like this. So in the product, if you observe in the product, there is R and NH2. Okay, like this. So this is how from the RCONH2 we are going to delete the CO and we are getting the product. As in this reaction, the product contains one carbon atom or CO less, or what you can say, one carbon atom less than that of the starting material. Therefore this is called as degradation reaction. Okay, I will write down that part here first of all. Before that, let me just write down the example. Yes, and apart from this, this reaction also gives some byproducts, and that is just a minute. Yes, if you are using Na2CO3, then it if you are using NaOH, then it will be Na2CO3. If you are using KOH, it will be K2CO3. Right? It depends on what is the base used in the reaction. Okay, RCONH2 is one product. RCONH2 is called as the primary amine. Okay, which is the main product of this reaction. Apart from that, this reaction gives some byproducts like If you are using NaOH, it is Na2CO3 sodium carbonate. If you are using potassium hydroxide, it is potassium carbonate plus 2 KBr, NaBr, sodium Br. If you are using potassium bromide, it is KBr plus 2H2O. Okay, so these are the side products or byproducts, right? The main product is NRNH2, right? Now in this reaction, what happens? The product contains one carbon atom less than that in the reactant, and hence this reaction is called as degradation reaction. Okay, because the product contains one carbon atom less as compared to that of the reactant. Okay, so this is the general reaction, guys. Now we are going to discuss the mechanism of this reaction. Before that, you can just do one thing. You can just take a screenshot of this page. Okay, yes, let us see the mechanism. Please listen the mechanism very carefully. You will not get this mechanism in your textbook. Okay, so this is a base catalyzed reaction because we are using base as a catalyst in this reaction. So base catalyzed reaction. Starting material is RCONH2. So first of all, I am writing that RCONH2. NH2 group I will split like this. Always remember, on NH2 or nitrogen there is a lone pair of electron. Okay, yes. Now lone pair of electron is present on nitrogen when it is attached to 3 atoms. Okay, then it reacts with the OH minus. OH minus comes from the NaOH, right? Like NaOH is dissociated into Na plus and OH minus, right? So this OH minus is nothing but this one. So OH minus means what? There is negative charge on oxygen of OH group. Negative charge means what? One lone pair extra. Ideally there should be 2 lone pairs on oxygen, but here there are 3. So this is the OH minus, right? Okay, now what happens here? First of all, this OH minus is a base, right? So base always abstract a proton, right? So this OH minus abstract this proton. Proton means only H plus without the lone pair of electron, and this lone pair of electron is shifted on nitrogen, right? Okay, let us see after the base abstract the proton, right? Like OH minus structure I will write down first of all. It is like this. Okay, 3 lone pairs of electrons are present on oxygen. Oxygen has negative charge, and this H plus is from the NH2 group, right? Hydrogen without electron. So this will be abstracted by OH minus and we will get HOH. Now oxygen will have only 2 lone pairs of electron, hence no charge, and this molecule is nothing but water molecule, right? This molecule is nothing but the water molecule. So this is how the first water molecule is lost at this step, right? So minus H2 I will write down. Can you see there are 2 water molecules generated, out of which the first is generated here. A byproduct is generated here. The byproduct I will write down below the arrow. so that I will get the space to write down the reactant and products. Okay, after loss of water proton, what is left with the reactant? RCONH containing two lone pairs of electron, and here having a negative charge, right? Okay, yes, now this is having a negative charge, that means extra electrons. So these extra electrons will be given to someone, because extra charge is nothing but instability, right? Okay, therefore that should be given to someone. Okay, so what happens here? It reacts further with the bromine. Okay, so that I will write down below. So bromine, that is Br2, there is a single bond in between two bromine atoms. Out of the two bromine atoms, always remember, one is delta negative, another is the delta positive. Delta stands for partial positive or negative charge, right? So what happens, this gets shifted on bromine, therefore one bromine will be left in the form of bromide ion, right? Then what happens, this negative charge will abstract this bromine, right? Okay, so this bromine is attached to this nitrogen, right? They will form a bond. What about this bromine? This bromine will be lost in the form of Br minus. Br minus means bromide ion, extra electron on it. Br minus is the bromide ion. So bromide ion will combine with Na plus. Now where is Na plus? Na plus from NaOH, right? Bromide ion will combine with Na plus and get converted to NaBr, sodium bromide. Can you see? We are getting two NaBr byproduct, out of which one is generated here. So I will write down that here below the arrow, minus NaBr, a byproduct, right? And what is the product then? Product will be R C double bond O as it is, N H Br. Now this nitrogen contains only one lone pair of electron and hence no charge present on it, right? So whatever product it is generated here is called as bromamide. It was amide, but one hydrogen has been replaced by bromine, therefore it is bromamide. Okay, it is bromamide. As this byproduct is generated during the course of reaction, this is also called as bromamide degradation reaction. Okay, yes, I hope you understood this step. I will delete this part first of all and write down the next step. Okay, bromamide is generated. What is after bromamide? So in bromamide also you can see there is still one hydrogen present on nitrogen, right? So that again reacts with the further OH minus ion, right? So that OH minus ion again abstracts this proton, right? Just like the previous step I have shown you, and this bond gets shifted on nitrogen. So here also there is loss of another molecule of water. Out of two, second molecule of water is lost here. What we are getting after this? We will get the R C double bond O N attached to Br, and this nitrogen is now having two lone pairs of electron and a negative charge. Why negative charge? Because it has one extra pair of electron. So this particular molecule in which there is a lone pair of electron or negative charge on nitrogen, this is highly unstable, right? Because negative charge is present. So it will, what it will do, it will lose this bromide ion, right? It will lose this bromide ion. So this bromide ion will again combine with Na plus. Where is Na plus? You know, we have used the base, so that base and has the Na plus. So this bromide ion and this Na plus, another NaBr formation I am telling you. So there will be formation of another NaBr. First it was formed here, second is formed here. Therefore we have seen in the reaction two bromide ion formation as a byproduct, right? Okay, so NaBr is lost. After loss of NaBr, what we are getting? R C double bond O attached to N and two lone pairs of electrons. Okay, and two lone pairs of electrons. So such a type of intermediate which is generated here this is a specific intermediate or special type of intermediate in which you can see there are two lone pairs of electron present on nitrogen and it is attached to one bond. Such a intermediate is called as nitrene intermediate. Okay, so they ask the question based on the intermediates also. The first intermediate which is generated here, okay, the names of intermediate. First intermediate is bromamide intermediate, right? What is the name of first intermediate? Bromamide intermediate. What is the name of another intermediate? Nitrene intermediate. So this is the second intermediate generated during the reaction, right? Okay, now again this is intermediate, this will further undergo some change, right? Okay, what kind of change it is going to take, let me just explain to you. So what happens here, so in this case, just give me a second, just a second. Okay, yes, so this is the nitrogen intermediate. Now this nitrogen intermediate will not stay as it is, it will undergo some rearrangement. So what kind of rearrangement it takes place, let me explain to you. Yes, so what happens here, this nitrogen gives its lone pair in between carbon to nitrogen bond, due to which this nitrogen is again electron deficient. Therefore R group, that is alkyl group, it gets shifted on nitrogen along with its lone pair of electron. I will repeat, I will show you again. What happens here, first of all, nitrogen gives its one pair of electron in between carbon and nitrogen bond, like this, in between carbon and nitrogen bond. So further there will be a double bond in between carbon nitrogen. And then what happens here, due to which this nitrogen previously it was having two lone pairs of electron, but one it has given, so it is needing electron. So R group along with the pair of electron, along with the bonding pair, these are the bonding pair of electron. R group takes both the bonding pair electron and gets shifted on nitrogen, right? So therefore this is called as a rearrangement reaction, right? So what is rearranging? The R groups gets, or R group rearrangement, right? R group rearrangement. Rearrangement means what, guys? If you observe the product and the reactant, there is no any difference in their number of atoms or nature of atom, just their positions are changed, that is the rearrangement. Okay, how to show that? First of all, I will write down the C. Okay, C is not going anywhere and O is also not going anywhere. Nitrogen and carbon, previously it was a single bond, but now converted to double bond, because nitrogen given its one lone pair of electron between the carbon nitrogen. Two nitrogen are with these electrons. These electrons are nothing but this bonding electron, because R has taken all the electrons with it and shifted to nitrogen. So that is here, and this nitrogen still it contains one lone pair of electron, because two were there, one has been shifted. So this is the new intermediate, which is also written sometimes as RnCO. Okay, so what is this RnCO? This intermediate is called as alkyl isocyanate. Okay, what is the name of this intermediate? Alkyl isocyanate, RnCO. In some books it is also written like this, RnCO. That is also the same thing if you observe. Both the this structure and both of these are the same things. Okay, no difference. Okay, so what is the next step here? The generation of alkyl isocyanate intermediate, right? Okay, then further what happens? This alkyl isocyanate intermediate, it reacts with the water molecule. Now that part I will show you. It reacts with the water molecule. Now we know H2O is the formula for water. We can write it like this also, in which OH is one part, H is one part. right? That means OH is the negative part, H is the positive part, right? So here what we are going to do, we are going to add the OH group across the double bond. Therefore OH is the addendum here, right? OH is the addendum. How to do that part, let us see. So here I will write down H OH, right? OH is the negative part, H is the positive part. Now here what happens further, the which bond to break, that is the question, right? Okay, so out of these two, the C2O bond will be broken because it will give you the stable structure, right? So bond will be shifted on oxygen, negative part will be attracted to the positive, positive to the negative. Hydrogen is positive, OH is the negative. Here oxygen is negative, carbon is the positive. Opposite attracts, right? Opposite parts you have to attach, right? Delta plus to delta minus and delta minus to delta plus, and we will get a product. I will write down the product now. So here this carbon to oxygen, it will be attached to H, right? H plus and O minus, opposite attracts. Then this carbon will be attached to what? Carbon will be attached to the OH from this water, like this. Then double bond N and then R, right? So this kind of product will be obtained here. Okay, now again what happens further, the after this you can see this is a diol, right? This is a diol. Diol means what? There are two OH groups attached on the same carbon atom. So this is unstable. So what happens further? It gets converted into the next molecule by again a rearrangement. What type of rearrangement takes place? So here what happens? This bond gets shifted in between carbon oxygen again, and this bond abstract this proton. So within the same molecule, H plus is shifted from one position to other. Therefore we write it like this: H plus minus H plus. That is plus minus H plus means what? H plus is shifted or transferred from one position to other. Plus minus H plus. Okay, yes. After this, let us see what we are getting. So it will be C double bond O. This will be OH only. Then this will be NH, right? H is shifted from O to N, and then this is R, right? This is also written as R NH COOH, right? You can see R NH COOH, right? And this is called as carbamic acid. Okay, so this is the another intermediate produced in this reaction, carbamic acid. Okay, they ask the question based on all these different types of intermediates. Okay, now again after this what happens? Yes, after this what happens? Yes, so after this what happens, guys? Again this bond gets shifted in between carbon and oxygen, and this get or this abstract this proton, right? So again here we are getting the hydrogen is shifted within the same molecule from one position to other. So I will write down plus minus H plus on the arrow, and what we are getting, C double bond O double bond O, right? Plus, that is carbon dioxide molecule, plus N H H and R, right? This N H H and R is nothing but R NH2. R NH2 is nothing but the product of this reaction, primary amine. Okay, now what happens? This CO2 gas which is produced here, it combines with the another molecule, another NaOH molecule, and it is converted into Na2CO3 further. But right now I will write down it like this only, right? It will not make any difference. So this is how we are getting what product? The primary amine, right? RNH2, which contain one carbon atom less than that of the starting material. You can do one thing. You can first take a screenshot of this reaction. You will never get such a kind of representation for the Huffman bromamide reaction in any textbook. You can take a screenshot of this reaction first of all, and then I will explain the reaction one more time. Okay, yes, done. Now after, yes, let me just see. Yes students, if you have any doubts in between, you can just go on asking me in the chat box, right? Yes, so I'll show you this mechanism again, and then we will see how to solve the question based on this. So I'll start with this. So this is nothing but Hoffman bromamide degradation. Just give me a second. Okay, so this is the Hoffman bromamide degradation reaction. This is nothing but the method of preparation of amines. In this, what we are going to do, we are taking the amide, treating with bromine and NaOH or KOH. We are getting primary amine as the main product. Side products are Na2CO3, NaBr and H2O. In this reaction, if you observe, the product contains, primary amine contains one carbon less than that of the starting material, that is amide. Therefore, this reaction is called as degradation reaction. Okay, this is called as degradation reaction. Then mechanism we have seen, NaOH or KOH, whatever you can use, it is going to produce the OH minus, that is a base. Base is having the tendency to abstract a proton. So proton from RCONH2 amide will be abstracted, and we are getting loss of water molecule. So this is the first byproduct generated, giving you negative charge on nitrogen. Then there is a role of bromine, and we are getting loss of NaBr and formation of bromamide intermediate, right? RCONHBr. There is again loss of another water molecule by attack of OH minus, and we are getting negative charge on nitrogen. Therefore, there is loss of bromide in the form of sodium bromide, and we are getting the next intermediate called as nitrine intermediate. Very, very important. In case of nitrine intermediate, nitrogen carries 2 lone pairs of electrons. So therefore, there is a rearrangement of R group. After rearrangement like this and this, here what happens, lone pair of electron on nitrogen is shifted in between carbon nitrogen, and R group along with the bonding electrons get shifted on nitrogen. Therefore, this is how we are getting a new intermediate RnCO, which is called as alkyl isocyanate. On addition of water on the alkyl isocyanate, we are getting first of all a diol, which is unstable. Therefore, we are getting, after transfer of H plus ion from one position to other, we are getting RNHCOOH, which is also called as carbamic acid. Carbamic acid again undergoes rearrangement, kind of like plus minus H plus, and we are getting the product RNH2, that is a primary amine which contains one carbon less than the starting material. So this is the mechanism for Hoffman bromamide degradation reaction. I hope you understood the mechanism. It was very easy to understand, but the thing is, you should remember what type of intermediates are getting generated during the mechanism of the reaction. You will not get the mechanism in this detailed form in any textbook. So this is really very important. I hope you have understood it. Now I'll show you how to write down the answers for the question based on Hoffman bromamide. If they give any starting material, and if they write down on the arrow Br2NaOH or Br2KOH, that is Hoffman bromamide degradation. How to write down the product? Very simple trick I am going to tell you. First example we will see. So it is CH3 C double bond O NH2, right? CH3 C double bond O NH2, which is nothing but acetamide, and if on the arrow Br2 and NaOH or KOH is written, right? So what will be the product? Very easy. Simply you have to remove this thing. Simply, okay, simply this thing you have to remove, and you have to attach CH3 and NH2 to each other, which is nothing but methylamine. Okay, methylamine. Very easy. Simply you are going to remove the CO, and remaining products you can write down Na2CO3 plus 2NaBr and 2H2O. These products are going to be common in all the reactions, right? Just the main product will change. Another example we can see, if it is CH3 CH3, whatever may be the skeleton beside, it will not make any difference. Okay, just you have to focus on CONH2. Okay, then again if on the arrow Br2NaOH or Br2KOH is written, what will be the product? Only main product I will write down henceforth, because this is common for all. Okay, yes, I will write down in the bracket, this is common for all. Okay, yes, so what will be the what will be the main product here? Simply delete this part, that's it, right? So CH3, CH, CH3, CH2, NH2, that's it. So this will be the product. Okay, now again if I am using this one, right, like benzene ring, whatever may be this, the beside this, it will not make any difference. CH2, CO, NH2, this is the amide. If on the arrow Br2 NaOH or KOH is written, okay, so in KOH Na will be replaced by K, that's it. So what we are getting the ring will remain as it is, no any difference in it. Okay, and then CH2 and NH2, that's it. Just the middle part you are going to delete. This is the benzylamine. Okay, so only you are going to do one thing, that is you are simply going to delete the middle part, right? Take a screenshot of this page. Okay, now some examples for aromatic amines we will see. All these three examples were for aliphatic. Some examples for aromatic amine, like if I am starting with this, like this is benzene ring, and if it is attached to amide group, CONH2 group. Okay, when benzene ring is directly attached to CONH2 group, this is benzamide. What is the name of this compound? Benzamide. Okay, if on the arrow Br2NaOH or Br2KOH is written, Br2NaOH or Br2KOH is written, again here also you are going to do the same thing. Simply delete this, simply delete this part, okay. So what we are getting, so this is your benzene ring, and it will be directly attached to NH2 now, right? And this is nothing but the aniline, right? What is the product generated? It is called as aniline, right? So this reaction is used for the preparation of primary amines. Okay, does not matter aliphatic or aromatic, we can prepare aliphatic as well as aromatic primary amines by using Hofmann bromamide degradation reaction. Okay, I hope you understood all the examples. Okay, yes, so that's all for today. In the next class we are going to discuss another topic from chemistry from class 12. Thank you so much for your precious time, guys. At last I'll just show you how to upload the DPP, daily practice problems, on portal. Yes, so this is a teacher's portal actually. So teacher will go to resources, and then in the writing material teacher will upload the daily practice problems, and here you will be able to see the DPPs on your portal also. In student portal also you will see the same thing. So these are the questions. You can download these questions, write down the answers on your notebook or any blank paper, and or any paper, and you can just take a picture of it and upload it here, so that teacher will be able to evaluate it in the action button. Okay, yes, so that's all about the today's topic. I hope you understood each and everything, and we will conclude here. Thank you so much, student, for your precious time, and all the best to you. Thank you so much. Take care.